are at LG Institute of Engineering and Technology. So today we are going to study few topics of system of linear equations and matrices. So let's begin with the first topic, that is system of homogeneous linear equations. A system of m homogeneous linear equations in n variables, that is x1, x2 up to xn, or simply a linear system, is a set of m linear equations each in n variable. Okay, so here we are considering m homogeneous linear equations in n variables. So it can be represented as a11x1 plus a12x2 plus so on up to a1 and xn is equal to 0. So whenever we have homogeneous equation, here on the right hand side we will have 0 always. Okay, then a21x1 plus a22x2 plus a2nxn equals to 0 and so on up to am1x1 plus am2x2 plus amnxn is equal to 0. Okay, so we are writing this linear system in this way. Now we will write these equations in a matrix form, that is ax is equal to 0. Here we are in right hand side we have 0, so here it will come 0 only, where A is equal to this coefficient matrix. Okay, so this is known as the coefficient matrix of order m cross n. Right, now x is equals to x1, x2 up to xn. This is a vector of order n cross 1, and this is a zero vector, that is it contains all the zeros in a column. Okay, so this is called null vector and it is of the order m cross 1. Next, we will study the solution of homogeneous system of linear equation using GaussianJordan method. Okay, so for the system of m linear equations in n variable, so there are total two possibilities of the solution. So the first one is system has exactly one solution, that means unique solution. Okay, and this exact one solution, so this one solution is x1 is equal to 0, x2 is equal to 0 and xn is equal to 0, means the answer of all variables is 0. Okay, next, so this solution is called a trivial solution. Okay, and the second type of solution is infinite solution. Right, now when the system of linear equation has one or more solution, okay, that is unique or infinite solution, then the system is said to be consistent. Okay, so now we will write this matrix A is to B, that is we will write this A matrix is to this B, and here we have B matrix as 0 vector. Okay, so this is called a augmented matrix of a given system of linear equations. Now to solve a system of linear equations, elementary row operations are used to reduce the augmented matrix to either row echelon form or reduced row echelon form. Okay, now in previous session we studied to reduce in row echelon form, and that method was known as Gauss elimination method. Okay, and today we will discuss to reduce the augmented matrix to reduced row echelon form, and this is known as Gauss-Jordan method. Okay, so whenever we will reduce it to reduced row echelon form, then this method is known as Gauss-Jordan method. Okay, now the Gauss-Jordan method for solving the linear system is as follows. The first step is we have to write the augmented matrix, that is A is to, here we have 0. Okay, then we will obtain reduced row echelon form, okay, by using elementary row operations. Then the third step is we will write the corresponding linear equations which we have obtained from reduced row echelon form, and at last we will solve the corresponding linear equations by back substitution method. Okay, so in this way you will get the solution using Gauss-Jordan method. Now let's begin with the example. Solve the following homogeneous system of linear equations by Gauss-Jordan method, and the equations are minus 2x1 plus x2 minus x3 is equal to 0, x1 plus 2x2 plus 3x3 is equal to 0, and 3x1 plus x3 is equal to 0. So let's begin with the solution. Firstly, we will write the matrix form of the system. So it is represented as, we have to write this coefficient, that is minus 2, 1 and minus 1. Okay. From the second equation we will get 1, 2, 3. And from the third equation 3. Here we don't have x2, so we will write 0 and at last 1. Into this variables are x1, x2, x3 equals to, here we have 0, so we will write 0. Now we will write the augmented matrix form of the system. So it is, this matrix A is to this 0. Okay, now we have to reduce it to first row echelon form and then to reduced row echelon form. Okay, so here we need 1. Okay, so what we will do, we will check whether we have 1 below to this number. Yes, we have this one, so we will bring this one over here. Okay, so using this operation, that is R12, so you will get the second row is now the first row, so 1, 2, 3, 0, and the first row is now second row, that is minus 2, 1, minus 1, and third row as it is. Okay, now the next step is to make this two numbers 0. Okay, so we will use the row operations. R2 plus 2R1. Here we have leading one at R1. So we will write R2 plus 2R1 and we will make the changes in R2. Okay, and to make this 0, we will write R3 minus 3R1 and we will make the changes in third row. Okay, so you will get this first row we will keep as it is. Okay, so from here just multiply this row 1 by 2. So you will get 2 minus 2, that is 0. Then 4 plus 1, so you will get 5. Then 6 minus 1, so you will get 5. And here we have 0, so it will remain 0 everywhere. Okay, now to make this term 0, what we will do? We will multiply it by minus 3, right? And we will add in this third row. So you will get minus 3 plus 3, that is 0. Then minus 6 plus 0, so minus 6. And minus 9 plus 1, so you will get minus 8, and here 0. Okay, now the next task is to make 1 over here. So what we will do, we will divide it by 5. So 1 upon 5 R2. R1 and R3 will remain same, and here we have 0, 1, 1, 0. Okay, now the next step is to make 0 over here. Okay, so we will write the operation R3. Now leading one is in this position. Okay, so we will write R3 plus 6R2. So we will multiply 6 over here and then we will add in this third row. So you will get this first two row will remain as it is, and here we have 0, then 6 minus 6, so you will get 0, then again 6 minus 8, so you will get minus 2, and again 0. Clear? Now the next task is to make 1 over here. So what we will do, we will divide it by minus 2. So minus 1 upon 2 R3. So you will get here 0, 0, 1, 0. The first and second row will remain as it is. Okay, so this is our row echelon form, right? And these are the leading one. You can see we have 0 below to the leading one. Now our next step is to find the reduced row echelon form. Okay, so for that firstly we will make 0 in this two position. So for that we will use this row operation, that is R1 minus 3R3. We will consider this leading one, right? So R1 minus 3R3 and we will make changes in the first row R1. Then to make this 0 we will write R2 minus R3 and we will make the changes in R2. Okay, so you will get this third row will remain as it is. Okay, so 0, 0, 1, 0 as it is, and we will get 0, 0 over here. Now here we have 0, so these terms will remain as it is. Okay, and in place of these two terms here we have 0. Okay, now the next step is to make 0 over here using this leading one. Okay, so you will use the operation R1 minus 2R2 and we will make the changes in first row. So you will get here 1, 0, 0, 0. Other term will remain as it is. Okay, so this is our reduced row echelon form, and these are the leading one. You can see that we have 0 everywhere in this particular column. Okay, now we will write the corresponding system of equations. So from this first we will get x1 is equal to 0. From this second you will get x2 is equal to 0, and this from third row you will get x3 is equal to 0. Okay, so here we have all the answers as 0. So this system has a trivial solution. Now let's begin with the next example. Solve the following homogeneous system of linear equations by Gauss-Jordan method. Equations are minus x1 plus x3 plus 2x4 is equal to 0, minus x1 plus x2 minus x4 is equal to 0, minus x2 plus x3 plus 3x4 is equal to 0, x1 minus 2x2 plus x3 plus 4x4 is equal to 0. Right? Now, firstly we will write the matrix form of the system. So it is given by, from here you have to write the coefficient, that is minus 1. Here we don't have x2, so we will write 0. So minus 1, 0, 1, 2. Okay, from here you will get minus 1, 1, 0 and minus 1. Then from here you will get 0, minus 1, 1 and 3. Right? And from here you will get 1, minus 2, 1 and 4. And the variables are x1, x2, x3, x4, and on the right hand side we have this 0 matrix. Okay. So we will write the augmented matrix form. So it is given by this form, that is matrix A is to this 0 vector. Okay, now we will make a row echelon form firstly, and then we will reduce it to reduced row echelon form. So for that we need 1 over here, right? So what we will do, we will bring that fourth column to the first column, that is we will use the operation R14. So you will get this fourth row is now the first row, and the first row is fourth row. This second and third row will remain as it is. Okay. Now the next step is to make 0 at these two places. Okay. So for that we will use the row operations as R2 plus R1, and we will make the changes in R2. Okay. And for this we will write R4 plus R1, and we will make the changes in R4. So the first and third row will remain as it is. We will make changes in R2 and R4, right? So for this, firstly add R1 and R2. So 1 minus 1 you will get 0. Then minus 2 plus 1. So you will get minus 1. 1 plus 0, that is 1. And 4 minus 1, so 3. Now we have to add R4 and R1. So 1 minus 1, 0. Then minus 2 plus 0. So you will get minus 2. Then 1 plus 1, so 2, and 4 plus 2, so you will get 6. And here we have 0, right? Now the next step is to make 1 over here. So we will multiply it by minus 1. So minus 1 R2, okay? Other 3, that is R1, R3 and R4 will remain as it is. And here we have 0, 1, minus 1, minus 3 and 0, okay? Now the next step is to make 0 at these two places. So what we will do? R3 plus R2, consider this leading one. Okay, so you will get R3 plus R2. We'll make changes in R3, and to make it 0 over here we will write R4 plus 2R2, and we'll make changes in R4. Okay, so you will get this first and second row as it is. Now we have to just add this two row, that is second row and third row. So 0 plus 0, 0, then 1 minus 1, 0. Then minus 1 plus 1, 0, minus 3 plus 3, 0. Okay, and here we have to multiply it by 2. Okay, multiply it by 2 and add in this fourth row. So you will get here 0 everywhere. Okay, now this is our row echelon form. Right, here we have this 2 as a leading one, and we have 0 below to the leading one. Now we will make reduced row echelon form. Okay, so for that we have to make 0 at this place only, right? So for that we will use 0 operation R1 plus 2R2, and we'll make changes in R1. So you will get here 1, 0, minus 1, minus 2, 0. Other 3 row will remain as it is. Okay, so this is our reduced row echelon form. Okay, and these two are leading one. We have 0 everywhere above and below to the leading one. Okay, Now from this we will write the corresponding system of equations. So you will get from the first row you will get x1 plus 0x2. So we will not write this 0x2. So we will write x1 minus x3 minus 2x4 is equal to 0. And from this second row we will write x2 minus x3 minus 3x4 is equal to 0. Right? Now make x1 and x2 as a subject. So you will get x1 is equal to x3 plus 2x4 and x2 is equal to x3 plus 3x4. Okay. Now we will suppose this x3 and x4 as k1 and k2. So you will get x1 as k1 plus 2k2 and x2 is equal to k1 plus 3k2. Okay. So here we can take any value of k1 and k2. Right. So here we have infinite solution. Right. So whenever we have a zero row, so you will get infinite solution at that time. Right. So in today's session, what we studied? Gauss-Jordan method for homogeneous system. Okay. So firstly, we will write this augmented matrix form. Here we have 0 because we are using a homogeneous equation. Okay. So what we have to do? Firstly, we will form RE form. Okay. That is row echelon form, and then we will find reduced row echelon form. Okay. And after this, you will get the system of equation, right? And from that, you will get the answer of x1, x2 and so on, xn, right, as 0 if the solution is trivial solution. Okay. And other you can get infinite solution. When you will get the infinite solution? When you will have a 0 row, then you will get infinite solution. Correct? So I hope you have understood in this session. Thank you for watching.